Introduction to trigonometry. In this video, we will see trigonometric ratios of the angle, examples related to trigonometric ratios of the angle. Examples from 1 to 5. We will see all the 5 examples in this video. Example 1. See, we will appreciate whatever we have learnt in the previous video. What we have learnt in the previous video? How the trigonometric ratios are defined by the mathematicians. Okay? How the name was derived from Greek words. Okay? And we have understood 6 trigonometric ratios in the previous video. Now in this video, what we will do, we will apply those concepts to understand the examples from 1 to 5. Okay? And these are all related to trigonometric ratios of the angle. Examples we are seeing. Example 1. What it is saying? Given tan A is equal to 4 by 3. What is tan A? Don't look at the diagram. Just let us understand. What is tan A? Tan A is, when you say A, tan A means what? Tangent of A. Tangent of angle A. Suppose if you consider triangle ABC, which is a right angle triangle, okay, it is given that tan A is equal to 4 by 3, which means what? Opposite side to angle A is BC divided by adjacent side is AB. What is the ratio of opposite side to adjacent side? BC by AB is nothing but tan A. We have learnt it, right, in the previous video? Yes. Now we have to draw a triangle. Okay, to solve the problem, we have to draw a triangle ABC. Yes, we have drawn a triangle ABC. Okay. Now we know that tan A is equal to BC by AB. Yes, just now I explained. Okay. Why BC by AB? Opposite side to angle A, this BC, and adjacent side to angle A, that is AB, is nothing but 4 by 3, which is given, right? Yes, 4 by 3. Now we appreciate trigonometric ratios are what? Is it? Trigonometric ratios are ratios of the sides of the triangle, correct? The tangent of angle A, okay? Tan of A, okay? Tan A is equal to BC by AB, that is 4 by 3. Therefore, now, what does it mean? BC by AB is equal to 4 by 3 means what? BC and AB in the ratio of 4:3, correct? Then, if you assume AB as 3, if you assume AB as 3K, it will be 4K, correct? Okay. Now, if BC is equal to 4K, then AB will be 3K, correct? They are in 4:3 ratio, right? Calculate the ratio, 4K by 3K, what? KK cancelled and 4 by 3 is nothing but 4 by 3. BC by AB is equal to 4 by 3. We are maintaining the same proportion, right? Ratio? Yes. Not proportion, sorry. Same ratio we are maintaining, right? Given the ratio, the trigonometric ratio is given as 4 by 3. What is tan A? 4K by 3K is nothing but 4 by 3, which is nothing but 4:3, correct? Yes. We are maintaining the same ratio. Yes. Now, what is the Pythagoras theorem? AC square is equal to AB square plus BC square. Now, AC square is equal to AB. What is AB? What is AB? 3K. Okay? Okay. Here K is a positive number, remember. Okay. If BC is equal to 4K and then AB is equal to 3K, where K is a positive number. Positive number, you can put a number. If you put 1, it will become 4 and this will become 3. Correct? Okay. If you put K is equal to 8 and this becomes 6. And what is the ratio? 8 by 6 is nothing but 4:3. So we are maintaining the given ratio. Correct? Trigonometric ratio, we are not changing anything with this assumption. Okay. Now using Pythagoras theorem, AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. We need to find out the hypotenuse of this right triangle. Okay. We know the trigonometric ratio. Okay. Okay. And by knowing this trigonometric ratio, we understood the sides are in the ratio 4:3. Correct? Now we have to identify we have to derive AC using Pythagoras theorem. Okay. Now AC square is equal to AB is what? 4K, correct? As per our assumption. 4K whole square. Okay. BC is 3K as per our assumption. 3K whole square. Now AC square is equal to 25K square. Okay. What happens? So AC is equal to 5K. You got it, right? Yes. Now we can write all the trigonometric ratios using their definitions. Yes. If this is 5K and this is 3K, this is 4K, the trigonometric ratios for angle A, we can write all of them. Now, what is sine A? Opposite side by, I am not using again the same nomenclature. Try to appreciate simply opposite side. This is hypotenuse, this is adjacent side when considering angle A. Now, sine A is equal to opposite side BC by hypotenuse AC, 4K by 5K. That is 4K by 5K is equal to 4 by 5. What is cos A? Cosine of A, that is cos A, is equal to adjacent side to angle A, that is 3K, or simply adjacent side 3K, that is AB. And hypotenuse is AC, which is derived as 5K using Pythagoras theorem. Okay. Now, cos A is equal to adjacent side AB by hypotenuse AC, 3K by 5K, which is nothing but KK cancelled and 3 by 5. And similarly, we can write all other ratios. What is cot A? Cot A is reciprocal of tan A, right? Tan A is already given. That means what? Reciprocal of tan A is 3 by 4. How we know that? By understanding the trigonometric ratios, we have observed that cot A is reciprocal of tan A. That is why no need to again you have to write cot A is equal to adjacent side by opposite side. No need to write. Simply you reverse the tan A. It becomes cot A. Correct? Cosecant A. Similarly, you can say cosecant A is equal to 1 by sin A, or reciprocal of sin A is nothing but 4 by 5 reverse 5 by 4. And cot A is reciprocal of 1 by tan A. Okay. Twice I have written. Please ignore this last one. Okay. Alright. Secant A, I think. Yeah, I did not write the secant A. What is secant A? Secant A is nothing but reciprocal of cos A. Please make a note of it. Reciprocal of cos A is nothing but 5 by 3. Here, instead of cot A, you please make a note. Secant A is equal to 1 by cos A is equal to 5 by 3. This please correct this. You strike off this cot A and you write secant A as 1 by cos A. Secant A is equal to 1 by cos A, which is equal to 5 by 3. Okay, alright. Example 1 is completed. We'll go to example 2. Right. What is it is saying? If angle B and angle Q are acute angles, okay? Acute angles means what? Less than 90 degrees, such that sin B in this triangle, sin B in ABC is equal to sin Q in PQ in this triangle PQR. Okay. Now let us consider two triangles ABC and PQR. Okay. It is given, right? Sin B is equal to sin Q, which is given, right? Sin B is what? Opposite side by hypotenuse. Opposite side is AC by AB. AC by AB. And what is sin Q? Opposite side PR by hypotenuse PQ. Yes, we have written. But as per the statement given in the question, both are equal, right? So that means what? AC by AB is equal to PR by PQ, correct? So what you do is, from this pair, what you do, you move this PR to here, move this AB to here, then it becomes, therefore AC by PR is equal to AB by PQ. Can we call this ratio as K? Yes, we can very well call this as some constant K. Now, using Pythagoras theorem. Now use Pythagoras theorem in this triangle ABC. Alright. Okay. What is BC? AB square minus AC square. Correct? Square root of AB square minus AC square. And QR is what? QR is equal to PQ square minus PR square under square root. Okay. Alright. So, BC by QR, what is this ratio? Calculate this. Square root of AB square minus AC square by square root of PQ square minus PR square, which is nothing but, what is AB? Can you see? AB is what? Consider this two. AB by PQ is equal to K. Then AB is equal to what? K times PQ, right? Then can I replace this AB as KP whole square? KPQ whole square, that means K square into K square PQ square. And what is this AC? AC is equal to K times PR, correct? AC is equal to, consider this AC by PR equal to K. Consider these two, this and this. Then AC is equal to KPR. That means AC square is equal to K square PR square. And retain this PQ square minus PR square as it is. Okay, then it becomes square root of K square PQ square minus K square PR square divided by square root of PQ square minus PR square. You take out this K out, okay, it becomes K square root of PQ square minus QR square divided by PQ square minus QR square. Now, this ratio BC divided by QR is equal to K. Okay, alright. From 1 and 2, what we can say? All three are equal. AC by PR, AB by PQ is equal to BC by QR. What we are trying to do here is the ratio of corresponding sides. You see, AC divided by PR, corresponding side, right? Corresponding heights, right? And corresponding hypotenuse, AB by PQ. Sorry, and the ratio of hypotenuse, okay, AB by PQ, and ratio of bases, BC by QR, okay. This is nothing but ratio of corresponding sides, right, which is K, no, K is a constant, correct. What does it mean? Then using theorem 6.4, triangle ACB is similar to, we have to read this statement as similar to triangle PRQ. Okay, using this theorem, we can say that angle B is equal to angle Q. How? What the theorem states? Please understand with this reference. If in two triangles, which are the two triangles? ABC, yes, ACB and PRQ. Okay, sides of one triangle are proportional to the sides of other triangle. Okay, then their corresponding angles are equal. Sides are proportional, just now we arrived, right? All the corresponding side ratio is constant, correct? They are in proportion, right? Yes. Okay, then the corresponding angles are equal. Corresponding angle is what? Angle P will be equal to angle Q, angle A will be equal to angle P, angle C will be equal to angle R. And hence the two triangles are similar. This criterion is referred to as SSS, side similarity criterion for two triangles. What does it mean? We have proven that the corresponding sides are in proportion. Okay? Okay, if they are in proportion, this theorem 6.4 says that all corresponding angles are equal. Okay, please be careful. Corresponding angles are equal, not all the angles are equal. Corresponding angles. What are the corresponding angles? Angle B is equal to angle Q, angle A is equal to angle P, angle C is equal to angle R. Which means, now what we have to prove? Angle B is equal to angle Q. As per theorem, this is proven. Right? Yes. Example 2, we have completed. We will go to example 3. Now consider this triangle ACB. ACB is right angled at C. This is right angle, right? Yes, this is right angle at C. in which AB is equal to 29 units. Units. They didn't specify centimeters or meters or mm like that. Units you can write in generic. In general you can write units. And BC is equal to 21, which is given, right? And angle ABC is theta. We have learnt in video 1, you can call this angle as theta, right, with Greek letter? Yes. Now it is asking that determine the values of cos square theta plus sin square theta and cos square theta minus sin square theta. Okay. Now, to proceed further, what we require? We need to know cos theta, we need to know sin theta. Okay. Okay. Then, to calculate cos theta, we require to calculate sin theta, we require opposite side, right? Opposite side to theta. AC we don't know. How we can calculate AC? We can use Pythagoras theorem. What is AC? AC is equal to AB square minus BC square. Correct? What is Pythagoras theorem? AB square is equal to AC square plus AB square is equal to AC square plus BC square. If you rearrange the terms, what happens? AC is equal to square root of AB square minus AB square minus BC square. AC is equal to this side is equal to AB square minus BC square. AB is 29 square, BC is 21 square. Can you see? This is in the form A square minus B square. Can you write it as A plus B into A minus B? Correct? Using the formula A plus B into A minus B is equal to A square minus B square. So, we rearrange the terms as A minus B into A plus B. It's nothing but A square minus B square, right? Now, AC is equal to square root of 400, which is equal to 20 units. Now, using Pythagoras theorem, we have derived that AC is equal to 20 units. Now, if you know all the sides, it is very much easy to specify the trigonometric ratios of this theta, of this angle B, which is denoted as theta in this particular problem. Correct? Now, sin theta. What is sin theta? Opposite side AC by hypotenuse AB. Nothing but 20 by 29. Okay. What is cos theta? Cos theta is equal to BC by AB, 21 by 29. Yes. Yes. Now, we need only sin theta, cos theta. We don't require to calculate all other trigonometric ratios like tan theta, cot theta, cosecant theta, tan, secant theta. Okay. These are not required. Why? In this problem, they are asking, okay, related to cos and sin theta only. Now, first one you consider cos square theta plus sin square theta. Now, what is cos theta? 21 by 20. Okay. What is cos theta? 21 by 29. 21 by 29 whole square. And what is sin theta? Just I reverse the terms, not a problem. Here I have written sin square theta plus cos theta. Both are same, right? Yeah. So, here, what is sin theta? 20 by 29 whole square. So, you take the LCM and it will become 20 square plus 21 square by 29 square. It is equal to 400 plus 441 by 841. 841 by 841 is equal to 1. So, what we have understood in upcoming topics, okay, we will understand what are trigonometric identities. Now, see. This is called trigonometric identity. Don't worry at this stage. Just understand this is called trigonometric identity. Sin square theta plus cos square theta is equal to 1. This is always 1. You take any triangle, whatever may be the angle, okay. If you calculate in that particular triangle, sin square theta plus cos square theta is always 1. Yes, it is. Remember that. Okay. Now, what is the second one? Cos square theta minus sin square theta. What is cos theta? 21 by 29 whole square minus sin theta. What is sin theta? 20 by 29 whole square. Okay. Now, LCM is 29 square and it is 21 plus 20 into 21 square minus 20 square. The same. A plus B into A minus B. 21 plus 20 into 21 minus 20. okay, is equal to how much? 41 by 841. This is the value. Now remember, sin square theta plus cos square theta is always 1 for any given angle in a right angle triangle. Okay, alright. We'll go to next problem. This is problem 4. Problem 4. Example 4. In a right triangle ABC, right angle at B, if tan A is equal to 1, what is tan A? AB by AC, right? Opposite tan A, sorry, this one. Tan A, opposite side is BC, BC by AB. It is saying that tan A is equal to 1. Then verify that 2 sin A cos A is equal to 1. The given that, what? Now we will see solution. In triangle ABC, we are considering this angle. Okay, we are considering this angle. If this is the angle A, what is opposite side? BC. What is adjacent side? AB. What is tan A? BC by AB. Can you see? Tan A is equal to 1, which is given, which is equal to BC by AC. Sorry, BC by AB. Please correct this. BC by AB. It is not AC. Sorry. BC by AB. BC by AB. Just strike off this line. Okay. BC by AB. Please write this one as BC by AB. BC by AB. You just strike off this AC and write AB. BC by AB is equal to 1. When BC by AB is equal to 1, what does it mean? BC will become, BC is equal to AB. BC is equal to AB. Means what? These two sides are equal. Now, if you assume that AB and equal to BC equal to K, where K is a positive number, this is K, correct? Then it becomes AC is equal to square root of AB square plus BC square. AC is equal to square root of K square plus K square, correct? Because both are equal, right? K and K. Then AC is equal to square root of K square plus K square, which is equal to 2 K square is equal to K root 2. AC is equal to K root 2. We derived that AC is equal to K root 2. Now, they are asking 2 into sin A into cos A should be equal to 1. Okay. Now, what is sin A? BC by AC, correct? BC by AC, that is, what is BC? 1 unit, right? Okay. And what is AC? Root 2. 1 by root 2. What is cos A? AB by AC. AB is what? 1. What is AC? Root 2. 1 by root 2. Now 2 into sin A into cos A. 2 into 1 by root 2, that is sin A. And what is cos A? 1 by root 2. Okay, 2 into 1 by root 2 into 1 by root 2. 1 by root 2, 1 by root 2 is equal to 1 by 2. 2 into 1 by root 2 into 1 by root 2 is equal to 1, which is the required value. Please correct this. In this example, please strike off this AC and write AB. Please make a correction. Don't forget to write this correction. BC by AB equal to 1. This one. BC by AB equal to 1. That is how it becomes BC equal to AB. Okay. We'll go to next slide, which is the last example for this video, example 5. In triangle PQ, in triangle OPQ, right angled at P, OP is equal to 7, okay, 7 cm, it is given, and given a relation between OQ and PQ. Relation between these two sides is equal to, how he has given, they have given the relation OQ minus PQ is equal to 1 centimeter. Means what? Difference between these two sides is equal to 1 centimeter. That is a given. Now determine the values of sin Q and cos Q. They have given one side OP and the relation between other two sides. Okay, now in triangle OPQ, OPQ, use a Pythagoras theorem. OQ square is equal to OP square plus PQ square. Okay. Now, what is OQ? From this equation, what we can write? From this equation, you can write OQ is equal to 1 plus PQ. Correct? See, we have substituted 1 plus PQ whole square on the left hand side. Right hand side, keep this as OP square, PQ square as PQ square. It is given Y. Why? The reason being, given that OQ minus PQ is equal to 1 centimeter. From this, we can deduce 1 plus PQ square, A plus B whole square formula, 1 plus A square plus B square, that is PQ square, plus 2PQ square. Okay, A square plus B square plus 2AB. I am sorry here, please correct this also. This is not 2PQ square, it is 2PQ. Please correct here. Please strike off this and write 2PQ. A plus B whole square, right? A square is 1, 1 square is 1, PQ square is PQ square, 2AB, 2 into 1 into PQ. That is 2PQ. It is not 2PQ square. Strike off this term and write 2PQ is equal to OP square plus PQ square. From this, what happens? PQ square cancel. Then 1 plus 2PQ, as we have corrected this as 2PQ, 1 plus 2PQ is equal to OP square. It is 7 square we have written. Why? Given that OP is equal to 7 centimeters, right? Yes. So 1 plus 2PQ is equal to 7 square. So which means 2PQ is equal to 48, PQ is equal to 24 centimeters. That means PQ, we derived it as 24 centimeters. PQ, we derived it as 24 centimeters. But OP is what? OP is equal to 1 plus PQ. That means OK is equal to 25 centimeters. Correct? OK is equal to 1 plus PQ. Just now we derived 24. 1 plus 24, OK is equal to 25 centimeters. So from this, we know all the sides. Okay, this is 25, this is 24, this is 7, 25, 24. Hypotenuse is always greater than other two sides, correct? Yes, in a right triangle. So here, what is sine Q? Sine of this Q, sine Q, angle A, sine of angle Q is equal to opposite side, that is OP divided by OQ, that is 7 by 25. Yes. And what is cos Q? Cos Q is adjacent side, that is PQ divided by hypotenuse OQ, that is 24 by 25. With this, we completed examples from 1 to 5. We have completed trigonometric ratios of the angle, related examples, that is 1 to 5.